We've got these robots. Just a few things to note. We designed and built these robots, so they're not really hardy. Okay, so don't let them drop, and please just be careful with them. The chassis we actually bought in. I can show you where to buy these from. They're not expensive actually, the chassis, but the clever bit is the circuit board. We made this, designed it, wrote the software for it and everything. Just a few points to be aware of. The only reason why this bit is on the back here, it's not a handle. Okay, now I've seen people carrying it as a handle, but it's not actually made as a handle. I didn't think of it that it might look like a handle when we designed it. But don't carry it by that, just carry it by the chassis. That's the strong bit, but not by this bit at the back. The only reason why we've got this bit is because there's a compass on here. The electronics do mess up the compass. So compasses are magnetically sensitive devices. The electronics, yes, it does make magnetism. Electricity makes magnetism, if you've done that in physics. And also we've got a great big motor underneath it as well. Just while I'm talking about the motor, please be aware you've got a big motor which is a powerful motor. You won't stop it when it's moving, okay, with a cogwheel attached to it. So just be very aware when that's driving to keep your fingers away from it, because it won't sense that your fingers are there and it will just keep taking skin off. Okay? So just be very careful, especially with autonomous driving vehicles. I've done this before. Program this to go to a location outside. It's gone to the location and I've programmed it to say stop when you're at the location. And you think, oh great, that was really cool. So you pick up the robot, not thinking, and then walk back with it, and then it starts driving itself again. You know, your fingers could be caught in the way. And not thinking, it's still running a program that says, if I'm close to that goal point, stop the motor. But if I'm far away from that goal point, drive the motors. So we didn't know that I was carrying it, but that was a bit of a shock. So just be aware, you know, keep it switched off, for example. Ultrasonic sensor, yeah, that bit at the front. It does, just so you know, it is on a turret, it is on a turning turret. We were talking about this turret that it's on today. It's a very weak servo motor, as you can probably see. It's a very small servo motor. These servo motors actually come from radio-controlled aeroplanes. That's why they were developed. So they're very small and very light. We're saying that actually this turret is almost too small. So please don't force it too much, because if you force it, it's only got plastic gears in, okay, and it will crack. We've had this happen quite a few times. So I'm turning it very gently. That's okay, but just be aware. Don't just go, you know, with it. Like I say, it is only a research robot. We've got a servo motor on the steering as well, and I don't really recommend you force it too much, but you can probably see if you turn that servo motor, it does turn the wheels left and right. Okay? Again, just turn it fairly gently. Don't force it round too fast, otherwise it will crack. Drive motor switch. Okay. Now the drive motor switch is this bit that's dangling down. You should all have something that's there, a little switch. It's not actually part of the chassis. It goes to a drive motor. That's a very important switch for you to know. Now on that switch you'll see that it's got on and off on it. Mine, there's some odd reason, is set to on. Please make sure it's set to off, so turn it off now. And the reason why is because that's a fail-safe switch which will stop the robot driving off the table. Because I really want that switch to only ever be on if you've got it on the ground. There is another switch on the circuit board which is here by these wires. Okay, so that is the main power to the robot. Now you might notice that there's two of these radio-controlled connectors. Okay, there's a battery underneath. Now mine's disconnected. I don't know if yours is connected or not. You can connect them if you like. So just make sure that red goes to red, black goes to black. But make sure that your drive motor is switched off, because it might do something. I can't say what program is in each of your robots. It might do anything, so it's unknown, okay? So if you have connected it, that's great. And then you can try turning it on if you like, as long as your drive motor's switched off. That switch there will just turn on the power to the robot. And your LCD might come on. Ah, this one's going through a test procedure, so it's doing LEDs flashing and things like that. I think, just to remind you that this test procedure, I think it does actually test the drive motor. So again, just make sure it's switched off, okay? You've probably noticed where connections are, and I just want to tell you about the connections because sometimes they might come out. Okay, so you've got your compass, which is connected, it should be connected to the chassis. So if your compass isn't working, it might have come out. You've got your ultrasonic sensor at the top, and also connected to the chassis. Now, a couple of important things. You've got your servo motors. They're the ones with the cables with the white, red and black wires on. So you've got one which is the drive, which is in the middle of the chassis, or the middle of the PCB, and then you've got the steer. So you can actually see those cables going to those separate motors. The steer goes to the steering motor, the drive actually goes underneath to a motor driver, and that motor driver is where the little switch comes out to drive, to turn on the motors or not. Okay, so it does you two drives. And the other one, which is, in mine is orange, black and red, that's the turret motor, okay, which turns the servo. So if any of those are not working, try and fix it yourself. If it's come out, you know, if it might be a cable that's just become disconnected. There's an accelerometer and gyro, which doesn't, although it's pointed to on here, it's not in at the time, but it's this little one that's right in the middle of the robot base, just above the LEDs. So that can tell whether it's tilting one way or tilting the other way, or which direction it's going in. Okay, so we use that as a gyroscope. So we're going to program the robot using C language. It's actually an Arduino. So the Arduino is the green or the orange bit in the middle, which is a microcontroller with a USB connector on the one side of it. Okay, so that's been pushed onto this PCB. So if you've used an Arduino before, you probably know it from looking at it the other way around. Okay, so it has pushed onto the PCB. Do check that it hasn't come off, because sometimes, and don't pull it off or anything, but sometimes it comes off the pins a little bit, so just make sure it's nicely at home on the printed circuit board. Okay, so we're going to program it in C, and I've got some information to help you with that. And what I want you to do now is just look at the chassis itself. So the chassis is the Scalp Chassis, and have a think about why is it so good to rough terrain, why is it so well suited. Just make sure you can find, that's the first bit. Then locate the motor interfaces, all of those cables I spoke about. Just make sure they're all plugged in and they're correct. Just make sure the drive motor's switched off as well.